Hi everyone, it's Sean. Welcome back to the channel. We're getting back on working to restore this Sparton 6-26 vintage radio receiver, what with both broadcast band and shortwave. And I'm at the point where I need to go ahead and start marking out all the components that I need and testing certain things. And this is really probably the second most longest portion of what it takes to accomplish, I guess segment is maybe a better term, what it takes to accomplish a radio restoration. Now, soldering in parts, replacement parts, now that does take the longest. But before that, identifying the components that we need and testing them, that's probably the second longest stretch of time it takes with restoring. And it is pretty straightforward. So like on the schematic we have right below, you see here on camera, this diagram, all I'm doing is I am matching up part identifications, like say C20 here, we got a 15 and a 10 microfarad capacitor. Here goes C20 over here, says 1510 microfarad electrolytic, which is hopefully our only electrolytics on here. And I know that to be this can, okay, based off of what is marked on it. But I will have to, go through and do the same thing with all of our capacitors and resistors, which means I'm going to be doing a good portion of this radio looking at it upside down. Now, right off the get-go, I am currently now believing that this is a replacement cap for that can. The way it's wired in, I'm kind of concerned if it was put in parallel, but I guess as I go through this, marking each one and marking it off on the diagram here to make sure I get everything identified, that I will learn what is supposed to be in here and what should come out when I put in my own replacement parts. Like I said, this is a bit time consuming. Now, concerning capacitors, all I'm doing is identifying them. They'll all get replaced, all right? And once I've identified the caps that I need to replace, anyone that I have not marked with a Sharpie marker, I know that that's been somebody else in here who has worked on this radio, and those were most likely replacement components at some point. As far as like resistors go, well, you can test them in circuit, but it's always best to at least cut one side of a lead, say like with this resistor right down here. Let's see if I can get a light on. We'll zoom in for a second. There we go. I'll move the camera down just a bit. So we know the resistance value based upon the our colored bands going across, these being 4-band carbon composite resistors. But typically what I like to do is I like to cut one of the legs, and then I'll measure with a volt ohm meter or multimeter the actual resistance, compare it to its values based off of its bands, and if it's within 20%, I'll leave it in. 10 or 20%, whatever is typical for these radios. And if not, then obviously those are going to get replaced as well. But this is going to be rather time consuming, like I said, so I'm going to get busy working on this, and when I'm done, I'll show you what all I've discovered, and we'll move on to the next thing. So yeah, this definitely took me a while to work through and figure out. So like I thought, this 16 microfarad cap does not belong in here. It's paralleled with the bad 15 microfarad here. You really shouldn't parallel caps like that. So we'll be taking it out, regardless if it's good or bad. We'll be putting in our own component. Oddly enough, this should be a 100 ohm resistor, 0.5 watt. It's burned up pretty bad. It's at 600 ohms. Should connect right down there. But that's been coupled with this 1 watt 1K resistor, which should be a 220 ohm 1 watt resistor instead of this Dawn bone resistor. So these obviously have been replaced before. That's been replaced before. A lot of these replaced caps are actually over voltage, which isn't bad. 0.05 microfarad, 600 volts, and what the schematic calls for is 400 volts, but that's not really going to be such a big deal. But I marked all the resistors that need to be replaced and all of our caps that need to be replaced. So really all I got to do now is just, look at my stock, see what I have in stock. I probably got most of these in stock, and then what I don't have, I'll put on order, and we can start replacing things. I was left part one with quite a few questions, especially with actually starting on part two and looking through all those components, seeing we had some resistor values that were increased and the other work that was done on the chassis. And I was kind of wondering if was compensation being done because our condensers or capacitors were starting to go bad. We have increased voltages, so the previous technicians who worked on this, that they try to compensate for it with higher value resistors instead of just swapping out the condensers or capacitors. That those two terms kind of interchangeable concerning a vintage radio. And I just kind of left with those questions, as well as why weren't we really getting reception. We know our vacuum tubes were very weak. That's probably why we weren't getting good reception. That's the most likely one of the biggest causes, but of course, given the state of the components, that's an equal cause. So those questions are still kind of just hanging in my air, and I don't really have a definitive answer to them yet. But what I do know is we have the parts we need. I've gotten all the capacitors and resistors I needed for replacing inside of this radio from Mauser, and all of our vacuum tubes. As a matter of fact, here goes a new rectifier, 5Y3, and I'll tell you what, why don't we put this into the vacuum tube tester and we'll look at the old one and new one and just do a quick comparison. Alright, so here goes the old rectifier, 5Y3, and we've got it set up 5B, 5C. We got two checks. We got to check both diodes, essentially, C and E. If I can get down here, let me zoom in. There we go. 5x3, we need to check C and E. Get my finger out of the way. Anyways, I'll turn it on. This will take a second to warm up. You're seeing this real time, how long it takes for these old devices. They're not instant. They take a minute to warm up. And as you can see, it is reading pretty weak, okay? Of course, there was no grid leakage as we tested previously, and no shorts. So I'm going to turn this off, take it from C, D, E. Check emissions again. Yeah, just a tired, very tired vacuum bulb. Okay, so let me take this one out. Turn that back to C. Here goes our new 5Y3 GT. This one is actually 4-pin versus 5. Hoping that's not going to be too much of an issue. I don't believe it will be, but it's definitely something we'll know soon enough whether or not that's going to be problematic. Alright, let's turn it on. Yeah, we're all the way in the green. My needle sticks a little bit on this, so that's why you see me tap it. That grid leakage will come down. And you see it going down right now. But as far as grid leakage goes, we're down in the green, so we're good. We can do a short test. A, B, C, D, E, F, G, H, I, J, K. and that's pretty normal because we do have a note here as far as normal shorts, so I'm not concerned about that. A, B, C, D, E. Let's go to E. Let's check emissions there. Up in green. Grid leakage is low. Sorry, didn't realize where I was recording. So yeah, we're really good. So I'm going to go through and check our other vacuum bulbs off camera. I'm not going to put you through all that nonsense again. And I'm not going to put in the new vacuum tubes into the radio yet. I'll leave the old ones in there while I'm working on it. But I think now's a good time to go ahead and start replacing components. Okay, so when it comes to starting out, what I'm going to do on this radio is I'm really just going to start with our electrolytic can that's on the other side of this right here. I'm soldering right now, so I've got my rings on. I'll probably end up taking them off, but at any point in time I need to power up or energize something, you know, word of advice, take rings and stuff off. Don't present yourself an opportunity for electrical shock. But I can tell using my multimeter and just kind of probing around. Okay, so move this out of the way. This is a ground point here, and it's actually, if I can get this to lock in, tied to this point right here. And so this feeds off, goes to our tubes, which if I look over here, that's actually going to be the 15 microfarad capacitor. Okay, then one side will also feed to R18, which is the 2700 ohm 5-watt resistor. And then you see like it does this little loop between R18. We got a line that feeds to the rectifier, or totally forgetting what this is called, but anyways, it will come back to me at some point. Well, we see that's coming around, and we got another tie point here going to the positive side of our 10 microfarad electrolytic. So if I was to actually follow that around, what they do is they just went from that resistor, okay, and they jumpered over to this side right here. Focus. There we go. Which is a bit odd because what they've done, instead of this being the 15 down at the bottom, that being the 10 right here, is they paralleled this 16 microfarad cap between the 10 and the ground. So all this is going to have to be redone, plus, you know, so R18 is going to get replaced at the same time. Then we have R8 all the way down there. Yeah, I've marked it. And then this was what was this one? I think I marked it 220 ohm, so that way I would be able to remember. There it goes, 220 ohms. So that's let's see, R8 100 ohms, and our 220 ohm, so R12 1-watt resistor. Hopefully that's a 1, maybe a 5. Of course, I marked through it on this one. I know I ordered the right thing though. Regardless, we're gonna have to replace all of those at the same time. Oh, I remember now. Filament. That's what that. Yeah, bottom section. Things come and go when you get older, and brain no longer worky as muchy anymore. But anyways, all this is going to have to get tidied up. It'd be better if I had a terminal strip, something akin to like that right there. See where you have different posts where I could just rebuild it. But more than likely, I'm just going to find a place to get the replacement capacitors onto the board, and then just build, and I'll hot melt them to the bottom of the chassis, and then we'll build off of that. But I suppose the best thing for me to do at this point is I'm just going to cut out this. We're going to get that out of the way, and I'll just begin to work with that kind of out of the way, just like that. With that 16 microfarad capacitor removed, I was just kind of curious how far it's drifted, and well, you can see that there. It's definitely gone up in value, pretty much to the next highest value, and then some more. So no bueno. But you know, a lot of radio enthusiasts, they would restuff these caps. This one's not original to the radio, only the can is. So I'm going to leave the can in, and like I said, mount a replacement cap somewhere in there and make it nice and pretty. And if you remember me saying, researching what components second most time consuming, ordering in new components, especially when you have to figure out the arrangement of everything to get it to work. Yeah, I've only done this section, but we've replaced, and it's been several hours, but I've replaced our 2 electrolytics, these 2 resistors that were going to here. That was it, R8, R12, R18, and I think this was R10. Yeah, R10, that's been replaced as well. And then rerouted, this wire was underneath here going to that post. It's now, since we're not tied to those electrolytics there anymore, it's rerouted this way. I had to pull back one of the red wires that was going to this post here as well. Well, actually both of these were going to this post, but I had to pull back one more red wire and route a new one all the way down to the bottom, right down there where you kind of see it there. Oddly enough, you know, with the electrolytics replaced, it might be a good opportunity for me to try to power up again, just to make sure I haven't done anything wrong, because I'll find out quick, fast, and in a hurry if I did. But oddly enough, I was looking, and yeah, we got a gimmick capacitor sitting right there. You see that one little wire coming off of this trimmer cap? Here's our trimmer cap. Here, I'll point it out using my stick. This trimmer right here, and we got one little wire that's feeding through our oscillator right here, this nice coil, and it's just looped around. This is a little gimmick capacitor. I'll make sure not to fudge with that at all. But yeah, well, let me clean up my desk just a tad bit from all this work. And yeah, we still got a ways to go, but now it would be a good opportunity for me to try to power it up again, just make sure that nothing's too far off. All right, so I'm going to engage a squint factor here. Get this turned on and keep my eye on that light bulb. And let's see what happens. Pilot lamps immediately come up. Not see much of anything there. All right, let me give this a minute. I'm gonna look around. Oh, do we have a little bit of life there? Yeah, sound at the speaker. Hey, we got a bit of life. Of course, that's very low, those weak tubes. Yeah, that definitely gives me some a good amount of trust and faith that the rest of this is going to go perfectly. So it's just going to be replacing all the rest of the capacitors that need to get replaced, and the few resistors that need to get replaced as well. Some had run up multiple values, but it is what it is. This is looking really good. I'll get to working on that next, and we'll come back and look at this again once I got all that complete. Well, now we're done. Every resistor I tested is out of tolerance, or at least outside of their tolerance band, and every film capacitor and R2 electrolytics have all been replaced. And yeah, I know these are still, you know, film capacitors. No, they're not the typical axial type that I traditionally use, but orange drops is what I had available for my own radio, and so that's what I went with. And when I use them, they seem to work pretty well. At least my father-in-law, when I did his radio, I used orange drops in it, and I've used them in one other, and they all seem to work just fine. But I suppose now is as good a time as any to let me set this upright. We'll replace all the vacuum tubes with the new ones, and we'll give the radio a spin and see how it sounds and how it performs. Alright, and as promised, let's give our first power up. Turn it on. Get the volume up. This is a tone adjustment, and we'll see what we get. Yeah, we're definitely in need of an alignment. Yeah, it's definitely alignment. Got some interference from our fan that's on and our halogen lamps in here, so if I was to turn the light off, that would go away. Yeah, I'm not getting anything on our shortwave. That sounds... I got hits at the speaker, but... that could simply just be way out of alignment. It's also not the best time of day. It's like it's wanting to receive somewhere here in the lower range. Well, no, I take it back. I needed to throw something on our antenna connector down here, our tie board, just to make a makeshift antenna. But we might have shortwave. It's wanting to receive. Something in there.
Por la niña y me dijo para dónde ir. Entonces tenía los brazos y los muslos moreteados con golpes. Y como ella, otra muchacha, ya ella se separó de ese hombre y tiene otra pareja, pero bueno, en este momento no ha sufrido eso, pero sí sufrió 2 pisas y aparte de eso la...
Is that Mexico or is that Cuba? What is that? So the alignment might not be too far off on AM or shortwave because we are getting reception. So it'll be interesting to see how all that turns out once we do an alignment on it. Of course, this is really just a very makeshift shortwave antenna. It's not proper at all, but it is working. Yeah. Huh? Switch back to AM. Yeah, there we go. Well, I mean, yeah, so what do we got left? We need to address the speaker. We need to align AM and shortwave, align our dial. Probably going to take care more on the chassis, get it a lot more cleaned up. I'll more than likely do that off camera. And then the console itself needs a bit of work too. So, oh, and we need to replace the power cord. But all that being said, I mean, you know, it's working. We're not drawing too much current, as you can see over there. The bulb is hardly lit. So, and yeah, I'm pretty happy with this. Well, anyways, if we'll pick back up with part 3 here soon. But anyways, if you're new to this channel and you're just discovering this this channel, please consider subscribing. Watch my videos. You'll probably find something that you'll enjoy. If you like this video, please give it a thumbs up. You know, talk it over in the comment section. More than happy to try to respond to the people I can get an opportunity to respond to. If you're in need of a repair or restoration, you can check out in my all my video description sections. There's a link to my Google site. You download a Word document, fill it out, email it to me, and we go from there. But that's going to be it for this video. This will wrap up part 2 of our Sparton 6-26 radio restoration. And And when we come back, we'll do some more things and hopefully some fun things for y'all to watch. That all being said, thank you for watching. Take care and goodbye. Bark.